Hello everyone, welcome to another video, and in this video I will talk a little bit more about this multiple pipe hanger script. I did go up to the point where some things you can do with this script, some things you still cannot do with this script, but okay, we must start somewhere and then we will optimize. I will show you how the script works on some examples. Over here you can see that, for example, if this is a first pipe, this is like second parallel pipe, and this pipe over here have some offset, some height, 2.4 meters, and it go up to here. Over here those two pipes, so first and second, have the same height, it's 1.4, and then this third pipe have some different height. So it is not necessary that along the entire route you have like same heights for all pipe. The script is able to detect for each hanger the position of each pipe and to adjust the hanger according. That now I have even more fields. I know that this is probably a lot, and I know that you can probably optimize this number of questions, but for me it is like, okay, let's first build the script, then we will optimize. So first of all we need to select pipes. We will. Then we need to know what is our host, so up to where we are going with our hangers. Over here I have some slab, spot elevation, so this like bottom elevation of this slab, it's 3.7. For me that is default value, because while I'm testing this script I'm using some default values. You can change this. What is the hanger spacing? You can leave it to be 1.25 meters, or you can type anything. Let's go with, I don't know, 1.5 meter. Initial offset, so if this is a starting point for our hangers, you can type 0 if you want to have immediately over here a hanger, or you can type, I don't know, 300, so that first hanger will be offset from that starting point for this value. Probably again you can inside the Dynamo group those pipes, and you can see how many of those pipes you have and how many of those parallel pipes you have. But when you have like different spacing and different heights, and when you filter vertical pipes, then I'm not sure that you can so easy group those pipes. So for me it's easier to ask the user how many of those parallel pipes we will have in this run. So it's 4 parallel pipes. And what is the maximum space between the pipes? And I'm talking over here about the horizontal space, so it's X and Y space. Why? Because I will need this as a margin when I group those pipes. You don't need to be very accurate. You can go into the floor plan. So this spacing between the pipes, for me it is 250 mm for each distance, but if you have somewhere, I don't know, 300, and on some other place you have 100, you should do this maximum distance and type it over here, and then the script will use that for the grouping of the pipes. Okay, finally we can run this. And also script use solid in order to detect the clash. That methodology is time consuming, but it is pretty accurate. So again, you can optimize that time which is needed to run the script. So okay, over here we did place hangers. They are all going to the same point, to 3.7 meters. So we are able to pick those different heights. That is okay. We have that initial spacing. So I have inside my script the part of the script which can detect this situation and delete this hanger. I didn't connect those last node. I will show you later in the script. I want to explain methodology how I will detect these situations. So if you want to know that, stay until the end of this video. Also, I will just briefly run same script for this example over here where we have some custom angle. So we will select pipes. So what we have here, okay, this is very simple situation. Again, we will detect this in our script and we will automatically delete this inside the script. Everything else is pretty much okay. This hanger was a problem and this hanger over here. Now I will delete those hangers. Let's go to Dynamo. And now this is like the entire script. So we have some input. This part over here you already know. It is dedicated for visualization. So when we need to show just a couple of those hangers or all of them, over here we want to filter vertical pipes. Over here we want to group elements basically. Over here we want to set all parameters regarding the width. Over here regarding the height, rotation, split points, and this part over here I will explain in detail. Okay, so now let's run the script. Again, let's run the script for this example over here so we can follow results. I think. Okay, now we have hangers. And this example, it is good also for explaining the rotation. So this is the part of the script where we will split our lines to the points. We will also offset that starting point and we will also rotate the hangers if needed. So, and over here we have some angle and we will need to rotate those hangers. So we did group our elements and I did, and let's see what we have here. So why we have 4 pipes. So if we follow our pipes, I would say that over here I did took just this route over here. So for the single system, for the single route, I did pick all pipes. 636, okay. 638, okay. 640, okay. So basically we did took only one entire route. We did convert pipes to lines. We wanted to detect starting point. That is okay. Now in order to offset our starting point, we did just translate that starting point. But before that, we needed to know direction. So for different lines will have different directions. This part over here is not related to these points and this geometry over here, but you can easily see that over here we have one direction, some other direction, third direction, and so on and so on. So before we translate, we need to know direction for our pipes, and also we need to know amount of the offset, and that we will read straight from the user input. So the user told us to offset that starting point for 400 millimeters, so we did, and that is how we did offset our starting point. And also over here, so the rotation, it's a very simple thing inside the Dynamo. I will try to explain. So how you will rotate any element inside the Dynamo. Let's say that we have something over here. So okay, if this is like our pipe route, and also if we have some coordinate system over here. I'm not sure if I already explained this. but never mind. So let's say this is x, this is y, and also now when we compare this x-axis vector with our pipe direction, we can see that when we compare this vector over here and this direction over here, we can say that, for example, we will have over here 45 degrees. So for the all hangers which we will be on this pipe, we need to rotate them for 45 degrees. Over here we have vector in this direction, over here we have vector in this direction. So for those hangers for this pipe we will need to have 90 degrees rotation, and this is parallel, so over here we do not need to rotate those elements which are on this pipe. We will see that over here with this node. So when we compare our pipe direction with vector of the x-axis, we will have over here the amount of rotation which we need to perform for the elements on those pipes. And don't be confused with this node over here. So initially I did model this entire family basically wrong. I didn't place family appropriately while I was modeling that family. So initially you need to rotate my family by 90 degrees in order to have alignment with this logic over here. So this is just my mistake. If you did model your family different, you can try to go without those additional 90 degrees. If everything is okay, you don't need this part over here. That is okay. Over here, I did split our pipelines to the points. How many points? Well, basically, we did in the user interface told to the Dynamo what is the space which we want to have between our hangers. So basically, we will split this curve in respect of that offset start point for some spacing, and for some lines we will have 3 points, for some other lines we will have 2 points, and we can see that over here. So over here we will have 2 hangers and 2 points. Over here we will have 3 hangers, again 2, again 3. Depends on the starting point and also that amount of spacing between the hangers. And finally, now when we have the points, when we have the family, we can now insert all those families, and after we insert those families we can perform rotation. So that is okay, but what will happen, let's also show, I will disconnect this part over here. Now I want to run this script again. So I did disconnect some flip node just to show you also that part of the script. What I did have as a problem when I was developing this script, my logic when I did model these families, that the origin for the family will actually be the first hanger. So I will always put the family to the first hanger, and all those differences into the height and width I will measure basically from this first hanger. And that was not so bad as an idea. But then when I did run the script, I did have this situation. So yes, Revit did place this family correct for the first hanger, but actually it needed to flip the family for some cases. Somewhere that was okay, so it did work from the first run, but for some other examples it didn't work at all, or it did work partially. So I needed at first create some logic which will check if I need to flip the family or not. So I did that. So I will wait for the script to set the height, to set the width of all hangers, and that is why I have this pass through. So I will wait for everything to be finished, and I will put everything over here. Wait for, I didn't need to put these unique items because it will wait anyway, even if I did go from here. But anyways, okay. And then in order to resolve that flip, I did start from these points over here. I did create 10 different hangers, 10 different elements, and that is like starting point for me. So what was my initial logic? So in order to detect if I need to flip those hangers or not, my idea was, okay, I did read at some point the diameter of each pipe, and I did set for each family diameter of the hanger. But in order to see if I need to flip this family or not, I did decrease this diameter just for 5 millimeters. Why? In order to create intentional collision. So when I decrease that diameter for 5 millimeters, and then when I run clash detection, if I don't have like perfect match, then I know that I need to flip the family. So I did took all the hangers, I did took the list of diameters, and I did decrease that diameter for 5 millimeters each, and then again I did set to my hangers this D1, 2, 3, and 4, which is the diameter for each hanger, to be smaller for 5 millimeters. I think this is not necessary anymore, but okay. Hangers, I did convert them to solids, and again, I know that this will demand some computational time in order to detect those collisions, but it's very accurate and we will easily optimize this in the future. So we want to have geometry of those hangers. And then what is very important for me, I don't need entire geometry of the hangers. So I did realize, I'll show you. So each family have different solids, and the solids which I need in order to detect collisions are always at the same index number. So it's 8, 10, 12, and 14. So it's 8, it's 12, it's 10, and 14. So now I did decrease diameter of those elements. I have those elements as a solid. Also, from the other hand, I have my pipes. So over here we have our list of selected pipes. That is also okay. I have them as a solid. I did flatten that list, and now basically I will try to detect a collision between those pieces of hangers and our pipes, and we will need to perform some optimization in order to find how many of those collisions we have. So if we have just one collision between the pipe and hanger, that will mean that we need to flip our family. If we have more than one, then we know that we don't need to flip those families. It is not good when we do not have one, which is a signal that we need to flip a family, and we don't have alignment of 4, 3, 2, 1, whatever we did select as a number of parallel pipes. But okay, then we will perform some additional check and we will need to delete this hanger over here. For all those hangers which have a collision number between the hangers and pipe 1, we will flip that families. So over here we do not need to flip the families for 2 hangers, but for those 8 we need to flip. So now when we connect this and run the script again, okay, so now Dynamo flip automatically all our hangers, but that is not enough, so we must also delete elements which does not have the same number of collision with the number of pipes. So again we will took all those hangers, we will flatten that list, again we will took we'll convert them as a solids. We'll took just some solids from that hanger family. We will again perform this does intercept. I'm not a fan. We could probably finish everything over here, but just have in mind that you don't have families on the proper position. So it can happen that you will make the conclusion when you have something like this. So you have only one, you know that you need to flip the family, but then when you flip the family, hanger can be over here. So you can, after a flipping of the family, you can have a perfect match, or either your family can be over here. So you will anyway need to delete that family. That is why I did finish with a check if I need to flip the element or not, and then again I will run the check if I need also to delete some elements. But in order to show this logic over here, I will need to freeze this logic over here for a moment because the idea is, let's check if we need to delete something. If we need to delete, we will delete, and then we will again adjust those diameters to be okay. So in order to show you entire logic, I will just again run the script. Now also over here you will see what is the impact of the fact when we say that we want to decrease that D1, D2, D3 and D4 values for 5 millimeters. So when we decrease this like hanger diameter, so now we did create intentionally collisions between the pipe. So this is a pipe and this is the solid of our hanger, and with that intentional decrease of diameter, we know that we in some cases need to have collisions, and then when we resolve and check everything, then we will set those diameters to be correct again. Let's now again take a look at that logic. So we did flip elements if we needed, then we did took pipes, we did took the hangers. So over here now we have perfect match for those 9 elements, but for this element we have only a match with 2 pipes. So all hangers have collision with 4 pipes because we have 4 parallel pipes, but this element over here have a collision just with 2 pipes, and that is a signal for us that we need to delete this element. So okay, now when we unfreeze this part over here, and now we know that we need to delete this element. So when we connect those 2 nodes, and now when we run the script, this element should disappear, and also what we just did also enable is to set back again those true values for D1, D2, D3 and D4. So now if we take a look, for example, this situation, and when we take a look those pipes and our hangers, so even when we go to the wireframe mode, now this hanger have a correct value for diameter for each pipe. So we don't have any more of those intentional collisions. And that is all for this script. I hope that you did learn something new. Also, there is a note that I did create this script for Revit 2019, and you know that for the 2019, when you're dealing with the pipes and the ducts, and you need to set a height, or you need to read the height, you're dealing with the offset parameter. If you want to use this script for any further version of the Revit, then you will need also to change parameter names for the pipes. Thank you for watching. Bye bye.